think we were till the this thing in flat slabs, moment calculation. Have we done the step number 5? Step number 5, moment calculations in flat slabs. This one. Moment calculations done. Hello. Moment calculation is done or not? Okay. Then the next one was the calculation of column strip and middle strips, which we are going to provide. Um, Page number 53, if we go to page number 53, you will see the column strip and middle strip. Okay. So this was in clause number 31.1.1 for the column strip. What was column strip? Column strip means a design strip having a width of 0.25 L2 but not greater than 0.25 L1. That means smaller of these two. So this is your column strip. From the center of the column 0.25 L2 or L1 that you have to calculate. Whichever is smaller is your column strip width. So that is for the longer span. Since here there are two different spans, longer span and shorter span, different lengths are given. So longer span, along the longer span, the width of the column strip is 0.25 L2 we have calculated. L2 is what? For the longer span. For the longer span, this longer span, what happens? This is your L2. This is L1. For the longer span, this is L1. This is L2. So from the center to center, it is L2. So L2 we have calculated. We got the sides. this one, that is this distance from center to here, from center of the column to till here. So into 2. So that gave you to be 2250. That means this entire thing from the center, it is this much, from here to here, it is 2250. And again we have to calculate what is 0.25 L1. That means 0.25 into this distance, the longer distance, 6 meter, whichever is smaller of these two. So we have calculated what, that our 0.25 L2 is smaller, 2250. So that means this is our column strip. Column strip means design whichever is smaller of these two on each side of the column, center to center line. Okay, so we got our column strip. Now when we got this along the longer span, we can calculate the width of the column strip. Okay, we can calculate the width of the column strip, which is 2250, and width of the middle strip will be how much now? Width of the middle strip will be how much? 4.5. If we subtract from 4.5, this half of this width, which is 2250, this one 2250. In column strip, we will have what, all these sides will be same. That means if from the center it is half of this is how much? 1125. Okay, so when it is 1125, that means from this center to this is 1125, and from here to here it is 1125, from here to here it is 1125, from here to here it is 1125. So now when we have to calculate the width of the middle strip, what we can do is this entire thing 4.5 minus our this and this, which is ultimately nothing but 2250. So we can directly subtract it. 4.54500 minus 11, this and this minus 1125. So that will give you this width of the middle strip. So 0.500 minus 2250. Now along the shorter span, if we see what is our width, we know along the, whether we calculate it from the longer span or along the shorter span, what will happen, our this width of the column strip from this side, it is always same. So it is 2250. Along the shorter span also it is 2250. But now what is your this thing along the shorter span, what is your width of the column strip? That means your this distance, see here, that means this is 6000. You will see here 6000 minus 2250. That means this from here to here 6000 minus your this and this will give you your this middle strip. That means this. Okay, so we can find it in this way for the shorter span, our mid width of the middle strip too. Now coming to the reinforcement along the longer direction, we have to go to page number 55, clause 31.4.3.2, page 55. Okay, see here, if we write in a table form the reinforcement along the longer direction, because we have to calculate the area of reinforcement required for along the longer span separately, along the shorter span separately. So what we have done, we have made a table here for which on which we are going to calculate this the area of reinforcement required for the negative moment, for the positive moment, what are the negative reinforcements, area of negative reinforcement, positive reinforcement along the column strip, along the middle strip. Okay, because that will, otherwise this calculations will become very long, and this will take you so many pages. So we can directly take it this on a table and just put down the values after calculating. So what we can do here, first of all, we will mention, since we are calculating the reinforcement along the longer direction, so we'll note down the movement along the longer direction was what? This one this one 264.6 kilonewton meter. So here we have placed that. Then we have calculated the okay depth of the, that is, this is the effective depth of the slab. Okay, that means, see, I think maybe we have not calculated in the previous step, but if I show you, that means we have to assume these things. Let me go to this, uh, where we were in the first step. We had calculated the depth of the this thing, this one. So here in the first step, what we did, we had calculated the depth, the overall effective depth, and then what we have done, we have assumed the diameter of bar 10 mm with a clearance of 20 mm. So now when we know the overall depth 200 mm, and we know the bar diameter we have assumed for our design to be 10 mm and a clear cover of 20 mm, so the effective depth will come out, this one, along the longer span. And along the shorter span, what we do, we keep a less, the we subtract the equal to the diameter of the bar, we just subtract, or you can say half of the clear cover we subtract from the effective depth of the longer span for the shorter span. So 175 was the effective depth of the longer span. We have kept it a little less along the shorter span, the effective depth, so we have just subtracted the half of the this clear cover. Okay, so this is our effective depth along the longer span. So we will place it again here on our this reinforcement table, this one. So here if we place our, this is our effective depth of the slab along the longer direction. We know the column strip width is 2250 for the longer direction, and for the middle strip width it is 2250. This one along the longer span, your width of the column strip is 2250, and it is 2250 also along the middle strip. Okay, so now when we go to this table, and we have to, for the column strip we will have different area of reinforcement for negative moment, for positive moment, similarly for the middle strip also will have. So here if we see the calculation of, this is the ultimate design moment, this one was the design moment, and this is the ultimate moment. Okay, calculation. So here if you see what is the 0.65, for that you have to go to clause number, page number 55, this clause you will see for the negative and positive design moment. Here, in an interior span, the total design moment MO shall be distributed in the following proportion. That means the negative, along the negative design moment, for the negative design moment 0.65, and for the positive design moment it is 0.35. Okay, so this much negative moment is to be distributed. So we have multiplied it by 0.65. This is our moment, the overall moment which we have calculated, design moment along the design moment for the longer span. So this one, with that we are going to multiply it by 0.65 for the negative moment. 0.65 moment, negative moment is to be distributed, that's why. And then what is your 0.75? To go to 0.75, what is your 0.75? You have to go to page number 57. If you go, positive moment, where is negative moment. So okay, this one. Clause number 31.5.5.1, column strip for the negative moment. This one. For the negative moment at an interior support, you will see at an interior support, the column strip shall be designed. The column strip for the negative moment should be designed in such a way so that it resists 75% of the total negative moment. Okay, so that's why what we have done, 75%, we have multiplied this because 75% along the negative for the column strip and along the negative moment and reinforcement, what we have to do, you have to design in such a way such that your 75% of the negative moment is resisted. Okay, so for a negative moment in the panel at the support, it is resisted. So we have multiplied it by 0.75. So we got, in this way we have calculated this for the negative uh, moment along the for the column strip for the negative moment. The alternate design moment we have got it to be 120.99 kilonewton meter. Now similarly for the positive moment, if you see, for the positive moment, now again if you go to page number 55, page number 55, earlier what we have done for the negative moment, we know we had to do what, we had to distribute this much 0.65 of the negative moment. And now wait, sorry, so for the positive moment we have 0.35. Okay, the total design moment ammo shall be distributed in, for the positive design moment, 0.35. Okay, so 0.35 is to be distributed for this design moment, so 0.35 we have multiplied here. And this 0.60, if we go again to page number 67, here you will see for the column strip positive moment, for its span, what is happening? For its span, the column strip shall be designed to resist 60% of the total positive moment. For the positive moment, when you are designing a column strip, the reinforcement, then what happens? 60% you should design in such a way so as that your 60% of the total positive moment is resisted. Okay. So here we have multiplied it by 0.60. So we got our ultimate moment for the column strip positive moment to be 55, 55.56 kilonewton meter. Now again for the middle strip, if we see the reinforcement, for the reinforcements, what are the moment that will be developed? Ultimate moment. Yes, same, for the negative moment, you have to 65.65 is to be distributed. Okay, for the negative moment. And now here, this is your what? This is your moment, the design moment. Okay, for the longer direction, along the longer direction, this is the design moment. But now here, why we have not calculated or we have multiplied it by 0.75 for the negative moment? Why? Because already we have designed here for the negative moment, we have already calculated here. That means we have distributed 75% of the negative moment here, so we are not going to do twice that thing. So we are going to subtract here from this calculation, we are going to subtract this 128.99. Since 0.75% we already have distributed a design for that, so we are going to subtract it, and the remaining, that is your moment for the middle strip negative moment. Now again for positive moment also similarly 0.35 this one, but 0.604 we have already designed in such a way so that our positive moment is going to resist this much. Okay, so we have subtracted this for the positive, since we have already distributed design in such a way our this thing that 60% is to be distributed of the positive moment, so this we are going to subtract here. So after subtracting, we are getting how much? 37.04 kilonewton meter. Once we are done with the ultimate design moment here, now we are going to go for the percentage of steel. How much percentage of steel is required? So here this is PT, okay. If I this is PT, percentage of steel required. So this is the formula for percentage of steel required. How you are going to calculate this? 50 FCK by Fy whole into 1 minus root over 1 minus root over, we have 4.6 mu by FCK into BD square, where you know the FCK value which is already given in your question. FCK is 20, M20, Fy is your, we know, 415. Okay, so if we calculate it here, how we can show it? Okay, whatever. So this FCK is how much? This FCK is 20. Fy is your 415, Fe 415 steel. We have into 1 minus root over 4.6 mu. Mu we have got for the negative moment here for the column strip. We have already got this one. If we see here, okay, this mu we know it is 128.99. Then FCK again we know it is 20. BD square. Now BD square, the D we know D is, that's why we have written here the D effective depth, we have to consider this. Okay, and then what is your B? The width of the width is written here already for the column strip. Negative moment, your width column strip width is 2250. So this will be 2250 right here, 2250. B is this much, and your D is effective depth 175 whole square. Okay, BD square. Mu we already know. Mu is this one, 128.99 kilonewton meter. So in this way, if you calculate the values, you will get for the negative moment the percentage is still required. For the positive moment, you will get for the middle strip. Also, you will get your percentage of steel here along with for the negative moment, for the positive moment. Okay, so in this way, you can calculate separately. For the middle strip again, it will be same thing, 50 FCK by Fy 1 minus root over 4.6 mu. Only mu is going to change here for positive moment, column strip positive moment. If you calculate the percentage of steel, your mu for this is going to change here, and B is going to remain same, FCK remains same, D we know it is 175 for the longer direction. So only mu value is going to change when you are calculating the percentage of steel for the column strip, for the middle strip, negative, whether it be negative or positive moment. So mu is going to change, and in this way you will get different percentages of steel. Now again, so we got our percentage of steel here. Okay, so once we got our percentage of steel, now we will calculate the total AST, the area of steel required, which is your percentage of steel into BD. Okay, So percentage of steel, for column strip negative moment, it is 0.59 percentage. So this one into BD square B, we know already this, the effective depth, this much. And we know this one, the effective depth here, this one. So, okay. So we have what here? Now the total AST we can find out for separately for the column strip negative moment, for the column strip positive moment, for the middle strip negative moment, for the this thing um, middle strip positive moment. So we have calculated in this way. It will take time because there are many calculations here. Okay, but the formulas or how to calculate it is same everywhere. Now, once we calculate the total area of steel required for the column strip negative moment, positive moment, middle strip negative moment, uh, middle strip positive moment, where our B is 2250 same for the middle strip also width, and also this D is the same. Only the percentage of steel is different. So once we have calculated our total area of steel, we can, this is the rough work, the calculation which I have done. So same thing, the total area of steel is done. So according to this, you can provide, you can assume your diameter of the bars and spacing you can provide. You can take different this thing. Whether you can take for here 16 mm diameter bars, here 16 mm you may take here 16 to 20. Then we have the spacing you can provide. When you know the area of steel, total area of steel, you can do these things, right? So next, again, similarly to the longer directions, however, the longer direction reinforcement we have calculated. Now, similarly to the shorter span, now again we have to form this table. We have to make this table, and we have to calculate the reinforcement for the along the shorter direction. So for the shorter direction, we had our moment 198.45. If we check this again here, what was our this one? The along the shorter direction, this was our moment 198.45 kilonewton meter. So for the shorter span, if we see, this was our moment. Our D, we had calculated the effective depth 165, because the overall depth of the, the effective depth of the longer, along the longer direction, we had given 175, and we had just reduced a very little amount, which is the from the clear cover, half of the clear cover we may subtract from the effective depth of the this thing, the longer along the longer direction, and so it was 165 mm. Okay, then column strip for the shorter direction we had 2250, for the middle strip it was 3750. This one, along the shorter direction, width of the middle strip was how much? 3750. So this is our 3750. So these steps are similar, same things are here, same calculations, only the moment has changed here, effective depth has changed, the column strip width and the middle strip width is changed. Okay. So here you know already, 65.65 percent is to be distributed here. Negative moment is to be distributed. Then 75% is to be resisted. Negative moment, and this is the moment you know. So this is the ultimate design moment after considering the IS provisions, whatever is given there. After following those, we get this much overall. The negative moments here on the column strip. For the positive strip, same, 35% is distributed and the 60% is resisted. This is in such a way, so it is, and this is your moment already, you know. Yeah, now here, one more thing. I told you there was a correction. If we go to the previous step, this one, we had got the correction. This one correction is required, therefore the correction is required. Along the shorter span, we had a correction required there for the pattern loading. So this was our, how much correction was required? Along the shorter direction, we had 1%. Okay. Very slow. So now you see here, we had a correction required along the shorter span. That means this shorter span, when we're calculating, we had a correction of 1%. That's why we are multiplying here on the this thing, the positive movement. 1.01 was our correction for the positive movement. Okay, and for the middle strip also, for the positive movement, we are going to give the correction. Okay. And similarly, other things are same. The percentage of steel, you will have 50 into FCK BD square, FCK by Fy into 1 minus root over 4.6 mu by this one FCK into BD square. Same thing, same formulas like in the longer span, whatever you have done. Similarly, in the shorter span also same. Then total AST, you will calculate same thing, the percentage of steel required for the B into D. So this was our total calculation of the area of reinforcement for the shorter span and for the longer span. Let me take my attendance here. So, section B. Today is 21. 44. 44. Please give your enrollments, attendance. 44, 64, 65, 64,
64.
65,
Yes, ma'am.
Ma'am.
65,
65 present,
66,
ma'am.
okay, 66, 67, 69,
Present, ma'am.
70, 71, 71, 72, 73,
73, ma'am.
74, 75,
Ma'am.
75,
75, ma'am.
76,
Yes, ma'am.
77, 78, 81, 82, 83, 84, 85,
85, ma'am.
86, 85, 86, 87, 88, 88 Sadiqul Islam, 88 Abu Talib Siddiqui,
Present, ma'am.
Ma'am,
Abu Jalal.
ma'am 82
89,
present, ma'am.
huh?
Ma'am 82.
82. 89, 90, 91, 92,
Present, ma'am.
92,
Ma'am,
93.
83 present.
Present, ma'am.
Okay, okay. And then we have 94,
Yes, ma'am.
95,
95, ma'am.
96. Okay, 96,
Yes, ma'am. 96.
97, 98, 100.
98, ma'am.
Okay, 100, 102, 103, 105, 107, 10, no, 110.
Yes, miss.
Okay, 11, 12, 15,
Yes, ma'am. 115.
16, 17,
Ma'am, 116. 116 present.
115 present, 116, 117, 119, 121,
Present,
122,
ma'am.
121, 122,
Yes.
123, 125, 126, 127, 128, 129.
128 present, ma'am.
Okay, 128, 130, 131. Okay, 131, 132,
Yes, ma'am.
133,
133.
135,
Yes, ma'am.
137, 138, 39, 40, 41,
Yes, ma'am. 139 present.
40, 41, 42, 47, 46.